Hi, this is Dr. B.J. Swaraprasad. In this series of lectures, I am going to deal with the course Design and Drawing of Hydraulic Structures, that is DDHS. So, let me introduce myself, Dr. B.J. Swaraprasad, Professor of Civil Engineering, G. Polarity Engineering College, Autonomous, Kurnool. So, for this particular course, the entire content of the syllabus may be covered into number of modules, that means units. So each unit maybe consists of 2 or 3 lecture videos of for a duration of 30 to 45 minutes. So this entire course, Design and Drawing of Hydraulic Structures, may be presented in 5 or 6 modules. These are the content of each module. So in general, this particular course, Design and Drawing of Hydraulic Structures, or in some cases, some universities or some institutions, it may be like Design and Drawing of irrigation structures or Design and Drawing of water resources structures, like that. All are similar in nature. So coming to the content, so this entire syllabus is divided into these 6 modules. Module 1, just introduction to DDHS, and next subsequent modules are Design and Drawing of Surplus Weir, and similarly tank sluice with a tower head, canal drop, canal regulator cum road bridge, and under tunnel. Most of the cases, as already said, so these are the major and common structures related to hydraulics. So academic point of view, so these are the major structures. Now in this particular class or video, I am going to brief introduction about DDHS. So this is the module 1, Introduction to Design and Drawing of Hydraulic Structures. So both it consists of design part and drawing part. So first of all, let me explain about the design features and design procedures. Later we will continue the drawing features also. So before going to introduce this particular course, these are some of the prerequisites. So to learn about the design concepts of all these hydraulic structures, so one can know about all these concepts. The first one is engineering hydrology. This may be one of the courses, most of the cases. So you are all aware about the hydrology. So let me brief out about this engineering hydrology. So hydrology is the science which deals with the occurrence, distribution and movement of water on the earth and also the below the earth. That part of science or engineering is called hydrology. So all the concepts of hydrology are required for this DDHS course. Similarly, another course by name irrigation engineering. So this is also already you might have covered before going to study this particular course. Why? Because this particular course is placed in most of the cases in the 7th semester or 8th semester of undergraduation BTech course. So that's why before going to follow this DDHS course, one can know about all these things, hydrology and irrigation engineering. Of course, irrigation is also a artificially supplying of water for growing of the crop. That particular field of engineering is called irrigation engineering. So therefore, with the basic knowledge of engineering hydrology and irrigation engineering, we can study with water resources projects, that is hydraulic projects, etc. So water resources projects are the major projects like dams, reservoirs, weirs, barrages, regulation works, CD works, etc. This all comes under hydraulic structures or irrigation structures. Very often we are going to use these two words, hydraulic structures and irrigation structures, because the hydraulic structures are the structures which are in contact with water. Hydro means water, that's why hydraulic structures means the structures which are in contact with water or water related structures. Similarly, Sometimes we can also use the word irrigation structures. So most of the hydraulic structures or water resources projects are meant for irrigation purpose. Irrigation is the major purpose for which all these structures are recommending. And also, as ours is the agricultural based country like India, so these irrigation is have that much importance. So therefore, now and then wherever we are using the word hydraulic structures means that implies irrigation structures also. The examples are like that. You are all aware about these words, familiar to these words: dams, reservoirs, weirs, barrages, regulation works, and cross drainage works, etc. Now coming to the design part, design of any hydraulic structure again consists of three parts, or we can divide the entire hydraulic design of hydraulic structures into three parts. They are hydrologic design, second one is the hydraulic design, third one is the structural design. So if you observe these three, there is similar in nature. All these three are design aspects only. What is the difference? So let me explain the difference between these three types of designs. The first of all, hydrologic design means so in which we are going to handle with the quantity of water and flow of water or rate of flow, etc. All are related to the water only. Or in other words, in the hydraulic design of any structure, we are going to deal with the quantity of water only. So in different aspects like quantity of water and flow of water, velocity of water, etc. That entire thing estimation of flood, flood forecasting, and flood routing, etc. These are all comes under hydrologic design. Coming to hydraulic design, in which so we are going to suggest the suitable shape and size of the structure. So in hydraulic design, so we are going to fix the shape and size in the sense dimensions of the structure, whatever the structure may be. Say for example, if we consider the dam, so in the hydraulic design of a dam, we are going to fix the height of the dam, length of the dam, top width, bottom width, etc. So these are all comes under hydraulic design. And third one, structural design. In case of structural design, so like all other engineering structures, here also we are going to check the stability and the safety of the structure under this structural design. That means what are the various forces acting on the structure and what are the stresses developed or induced within that structure, whether the proposed hydraulic design is suitable or sufficient or not for withstanding all these forces and stresses, etc. These are all deal with structural design. So therefore, any hydraulic structure, design of hydraulic structure essentially consists of these three parts of the designs: hydrologic design, hydraulic design, and structural design. But most of the cases we are more concentrating on first two parts only rather than the third one. Why? Because here the more importance is given to the water, so therefore hydrologic design, and also the second preference is for hydraulic design. Of course, the third structural design also we are going to handle here, but limited extent only. Now, as per the syllabus mentioned in this particular course, that is design and drawing of hydraulic structures. So these are the 5 major structures to be designed. So again, these 5 structures, as mentioned earlier, can be divided into 2 categories. If you observe, the first 2 structures are similar in nature and the remaining 3 structures are similar in nature. So what is the difference between these two? Let me explain the difference among these 5 structures. If you observe, the surplus weir and the second one is the tank sluice with tower head. So these 2 structures are purely related to a tank. Tank in the sense just like a small reservoir. So therefore the surplus weir and tank sluice with a tower head or simply tank sluice are purely related to the tank. Tank means a small reservoir, or in Telugu it may called as a cheruvu. So surplus weir, the weir we are all aware. Weir means the structure over which the excess water or surplus water may flow. So that's why for every a tank it is essential to provide a weir called surplus weir. So the main purpose of the surplus weir is to discharge the surplus water or excess water to be stored in the reservoir or a tank. The second one is sluice, tank sluice. It is also related to tank, to be provided for any irrigation tank. So with the tower head. So therefore these two structures related to tank. Similarly, the remaining three structures, if we observe, that is a canal drop, notch type canal drop, canal regulator cum road bridge, and under tunnel. So these three are purely related to a canal system. If you observe any canal system, major canal system, so it essentially consists of these type of structures. These are very common. So very often we can observe these structures for any canal system. So let me differentiate these three. So drop or a fall to be provided for a canal along its length. Number of drops or number of falls are to be provided for every canal system. The necessity of canal drop and the functions of canal drop, you are all aware about those things. So anyhow, while designing this particular structure, further we will discuss about all these things related to canal drop. Similarly, the second one is canal regulator cum road bridge. So regulation, this is some sort of regulation work. So regulation means having the shutters or gates, etc., to regulate the flow in the canal. So often these regulators are combined with bridges, road bridges. So we can see in number of cases like regulator cum road bridges for any canal system like KC canal system or HNSS canal system, etc. So number of such type of structures can be observed. And the third one is under tunnel. So actually this is a case of a cross drainage work. We are all aware about the CD works, cross drainage works. One of the cross drainage work, CD work, is the type 2 siphon aqueduct. Aqueducts are there. So again, aqueducts are different types. Three types of aqueducts we have. So type 1, type 2, type 3. So this particular structure, that is under tunnel, is a case of type 2 siphon aqueduct. So therefore, in this entire course, we are going to study about the design and drawing of all these 5 structures. Of course, this is the syllabus framed for this particular course, that is DDHS, design and drawing of hydraulic structures. So design of surplus weir, design of tank sluice with tower head, design of canal drop, notch type canal drop, and canal regulator cum road bridge, and also under tunnel. So these are the various topics to be covered under each structure. Anyhow, we will discuss in detail about all these concepts while designing the structure separately. So this is the course outcomes. As per NBA requirements, you are all aware that. So for each and every course, we must frame certain outcomes. So these are the course outcomes for this particular course, that is design and drawing of hydraulic structures. So they are, at the end of the course, the student will be able to, the first course outcome is design the components of tank sluice and surplus work of a tank. This is the one of the outcome. So that means at the end of the course, the student will be able to design all the components of tank sluice as well as the surplus work. And similarly, next outcome is design the canal drop and canal regulator cum road bridge. So again, the student will be able to design both the canal drop as well as canal regulation work, that is canal regulator. And the third one is coming to the drawing. So the students will also able to draw the features of surplus weir and sluice of the tank. And similarly, design of abutments, wing walls, return walls, and of the irrigation structures. So this CO4, course outcome 4, is common in nature, which is required for all the structures. That's why it is common. So the abutments, wing walls and return walls are common features of almost all the hydraulic structures. That's why at the end of this course, students will be able to design all such type of design components. And the fifth outcome is stability. So student can also be able to check the stability of side walls of the barrel for tank sluice as well as pier of a canal regulator. So that means ultimately they will be able to check the stability of such type of hydraulic structures. That means stability analysis. So a complete idea about the stability analysis can also be acquired from this course. The last one is the course outcome number 6 is students will be able to draw the features of canal drop, canal regulator, cum road bridge and under tunnel. So that means, so ultimately any student after the completion of this course will be able to design all 5 hydraulic structures as well as able to draw the important features of all these hydraulic structures. So as part of introduction, before going to take up the design of all structures, we should know about this terminology related to hydraulic structures or hydrology. Now first of all, catchment area. So this is one of the common term or common word we are using in water resources engineering. The catchment area means it can be defined like this: the tract or the extent of the land draining into the any stream or a reservoir. That is called catchment area, generally expressed in terms of hectares or square kilometers or acres, like that, area units only. So often it may be also called as drainage basin or river basin, like that. So more or less all are giving the same meaning: catchment area or drainage basin or river basin, to be expressed in terms of square kilometers, right? That is called catchment area. Next word is flood discharge. So first of all, what is flood? Discharge means rate of flow. Everybody knows about the discharge. Discharge means rate of flow or the rate at which water is flowing. That is called discharge. So flood means the instantaneous flow from any catchment is known as flood. So this is also a common term. Very often we are going to use this word flood. So and correspondingly flood discharge. So flood means the instantaneous flow, sudden flow occurred in any river or a stream, so from the catchment area. That is called flood discharge. And then some abbreviations also there we are going to use in the entire our course. One is FRL or FTL. FRL means full reservoir level. These are all the relative levels. So that means in elevation, altitude, so different stages we have to represent. So one of such a level is full reservoir level. This is related to a reservoir. So one of the important hydraulic particulars of a reservoir is FRL. FRL means full reservoir level. Similarly, in case of a tank, it is called FTL, full tank level. So if a reservoir is there, it is called FRL. If tank is there, we have to consider as FTL, full tank level. So both will represent the maximum water level or level of water at full condition. Similarly, MWL and HFL. So MWL means maximum water level. So you have to observe the difference between these two. Maximum water level. Full reservoir is different, maximum water level is different. Similarly, high flood level. HFL means high flood level. So occasionally, not in regular. So occasionally we might have observed this maximum water level and high flood level during the floods only. So therefore, so we have to observe or consider relative levels or relative positions of water surface in case of a reservoir and tank with respect to FRL and FTL, MWL and HFL. Similarly, one more term, freeboard. We are all aware about the freeboard. It may be applicable for any water storage like a reservoir, tank or overhead tank, etc. So freeboard means the gap between the maximum water level and top of the structure. So if it is a reservoir, the top of the reservoir, the top of the dam, and maximum water level, the gap between the maximum water level and the top of the dam is called freeboard in case of a reservoir and dam. Similarly, in case of a tank, a small or medium tank, the gap between the maximum water level and the tank bund top level is called freeboard. And another technical term is crest level or sill level. Crest or sill. So it may be defined like this. Crest means the level above which water is flowing. Similarly, sill, S-I-L-L, sill. Sill is also will give the similar meaning. Sill level means the level above which water is flowing. Especially in case of dams and reservoirs or tanks, sluices, weirs, barrages, etc. We are using this word. It is one of the most important hydraulic feature, crest level. So this is also a RL, reduced level, and that means in with respect to mean sea level, we have to represent these levels, crest level and sill level. Now coming to some more terms or definitions related to all these hydraulic structures. Why? Because they are all common to all the structures. That's why at the beginning itself you should have some idea about all these terms. That's why the terminology and the abbreviations are very important. So let us consider this set of terms: sluice, ventway and barrel. What is sluice, what is ventway and what is barrel? So similarly, these three are similar in nature. Sluice means opening. In simple manner, we can define sluice as a opening. In general, it is circular in shape. Circular opening provided for any structure is called sluice. For example, if you consider a tank or irrigation tank, so number of sluices can be provided for the tank. So to the tank, through the tank bund, if you provide a hole of circular shape, that is called a sluice. Similarly, ventway. Ventway is also a opening, but is in general it is in rectangular shape. So sometimes we can use this term also, depends upon the type of and the nature of structure. Ventway means it is also opening, rectangular in shape, not only for serving the purpose of supplying water, that is a flow cross section area, but also some additional space if required can be provided by means of ventway. So that's why the sluice is purely to allow the water to flow, whereas ventway is not only for flowing water but also for working space. Some space, additional space can be provided within ventway. That is called ventway. So as a difference, sluice is circular in shape, whereas ventway is rectangular in shape. Barrel. Barrel is also similar term. It may be used for certain structures like regulation works, regulators, etc. In such case, barrel is the space between the two adjacent piers. So that means it is also in rectangular shape. Next one is a pier. Pier is nothing but a vertical structure or vertical component like a column, similar in nature column. Pier is the supporting structure for any major hydraulic structures like cross drainage works or regulators, etc. So just imagine it is as a column. So heavy shaped column is called pier. Especially for hydraulic structures, we are going to use this word pier instead of a column. Similarly, cistern. Cistern means the depressed portion in the floor having some providing certain water cushioning. So that is called a cistern. And then this couple of terms, splay and batter. So these are very important terms in especially drawing features for any hydraulic structure. What is splay and what is batter? Some similarities as well as some differences are there. So let us discuss about the splay and batter. Splay means the splay gives the angle of deviation. Say for example, if you consider any structure, so the relative positions of the components of the structure may be expressed in terms of splay. Say for example, if you have one weir wall followed by adjacent to it a abutment, so there, and also wing walls, so these are all interconnected or interrelated. So therefore splay has to be used, the term splay has to be used while drawing the plan, that is top view of the structure. So say for example, let me give one example for this splay. Weir wall and wing walls are right angle to each other. So therefore, but not exactly right angle, it is having some deviation. So therefore, these wing walls are to be splayed with respect to the weir wall. So that's why splay has to be used on plan. While representing the plan of any structure, we might have observed this word splay. Say for example, splay of 1:3 or 1:5, like that we can mention. Whereas the batter is different. Batter is also represent the slope, but is in vertical plane. Batter. So for example, if you represent any cross-sectional view of the structure, so since it has both sides the slope, so the upstream side as well as the downstream side, this slope may be expressed in terms of batter. So instead of this is the term slope may be replaced by the batter. So therefore batter may be also used often while representing the side slopes of the vertical structure. Say for example, a weir wall of a front batter of 1:8 or 1:7, like that. So that means for 7 vertical, 1 horizontal, that is the slope may be represented like that. Say for example, batter of 1:8. What does it mean? Batter of 1:8 means for every 8 units in vertical elevation, 1 unit in horizontal deviation. Like that we can represent the batter also. And coming to the protective works of any hydraulic structure like surplus weir, tank sluice, canal drop, etc., these 3 are very common. So these are the common features for all the hydraulic structures. They are abutment, wing wall and return wall. So these are all similar in nature. We can also consider these 3 as the retaining wall. So you have some idea about the retaining wall, the concept of retaining wall. So therefore we can see one face of this wall and the other side, rear side of the wall may be filled with earth fill. So therefore all these components like abutment, wing walls and return walls are like retaining walls only. So therefore while designing these components, we should keep in mind the design of retaining walls. Retaining wall concepts, if you know, you can easily design all these 3 components. They are similar in nature and most of the features are common for all these 3. Next one is the apron. Apron means a solid impervious floor. So it is the impervious floor to be provided on the downstream side of the any structure. Say for example, again if you consider the surplus weir or tank sluice or canal regulator, etc., on the downstream side of the structure, essentially it is to be provided a solid apron in the form of a impervious floor. So up to a certain extent we have to provide this impervious floor to protect the structure against the soil erosion or impact of falling water on the downstream side, etc. So this is also one of the important components parts of the structure. Similarly, revetments, bed pitching and talus, these are all similar in nature. They are related to stone masonry. So apart from these abutments, wing walls and return walls as protective works, we have to also provide these revetments, bed pitching and talus to the structures. Revetment means so one layer of stones on the sloping side of the structure. If any structure having some sloping face on which, so for as part of protective work, we need to provide the revetment. So that means one layer of stones to be provided as the revetment. Similarly, if same can provide on the bed of the horizontal floor, it is called bed pitching. Since it is providing on the bed of the structure like a canal or downstream of the river, downstream of the weir, etc., that is called bed pitching. Similarly, talus also a temporary provision to protect the soil erosion on the downstream side of the structure. Therefore, the revetments, bed pitching and talus are in terms of stone masonry, which is to be provided on the downstream side of the structure. These are all some of the common features or terminology related to design of any hydraulic structure. Similarly, the next part is drawing. So coming to the drawing items, anyhow we will discuss in detail about these features while dealing with drawing classes. So anyhow, the 5 important features of the drawing of any hydraulic structures are like this. So one is, you are all aware about the scale. So for any drawing, we have to adopt the suitable scale. Scale is the representative factor. You are all aware that. So say for example, scale of 1:100. Suppose if you want to draw any structure with a scale of 1:100, that means 1:100 means, so 100 units on the field are to be represented as 1 unit on the drawing. Simple manner. We can define the scale like that. Say 1:100. I will repeat once again. Scale of 1:100 means, so 100 units, whatever the unit may be, either meters or feet or whatever the length unit may be. So that has to be represented as 1 unit. So best example is 1:100. 100 meters. 100 meters of any structure has to be represented as 1 meter on the paper. So that is called 1:100 scale. So it is very, very important and essential to represent the scale for all the drawings. So it is the essential requirement. First of all, before going to start the drawing, everybody should represent the scale on the drawing. Now, the drawing features are these 4 major features we have to draw, especially for these hydraulic structures. Plan, everybody knows plan means, plan is the top view of the structure. It may be building or a dam or any other structure. Suppose if you want to draw the plan means, it represents, what does it represent? It represents the top view. So but in this particular case for hydraulic structures, the plan, whatever the plan we are providing, we are drawing is half plan at top and half plan at foundation. There is a reason for this. Since it is not able to draw all the features, entire components, all the components of the structure in a single paper or single page, it is highly difficult. So therefore, for our convenience, we are going to represent the plan into 2 parts. Half portion of the structure at top, half portion of the structure at foundation level. So therefore, we can cover all the features of the structure. It is more convenient also. So that's why for all the hydraulic structures, plan means a half plan at the top and half plan at foundation level. Of course, remaining features, longitudinal section and longitudinal elevation, sectional view and elevation. Elevation means the front view elevation, rear elevation, like that means in the vertical plane. Whatever the features observed in the vertical plane are to be represented in elevation. So if it is along the length of the structure, that is called longitudinal elevation. Similarly, cross sections also, wherever it is required at a particular section or particular position, we can have the cross sections of also. The cross section is also known as profile. So all these drawing features we can further discuss in detail while dealing with the drawing of the structures. So therefore, now let me conclude about this introduction part of this DDHS. So in this case, we have discussed about the various types of hydraulic structures, syllabus content, course outcomes, and most importantly, the terminology and certain abbreviations and definitions related to hydraulic structures. I hope it is clear, and further we can continue in the next module. For each structure, maybe 1 or 2 modules, I will try to cover the entire design of the structures. So thank you.